When you mash the throttle in a traditional, naturally aspirated V12 supercar, there is a delay. It's a fraction of a second, where the engine inhales air, builds RPMs, and transfers that rotating violence down to the pavement before the tires hook up and launch. The 2026 Lamborghini Fenomeno Roadster is engineered to obliterate that exact mechanical hesitation. To solve the physics problem of internal combustion, Lamborghini wired 3 electric motors directly into their most aggressive V12 engine. They didn't do this to maximize fuel economy. They did it to manipulate the acceleration physics of an open-top hypercar. Traditional hypercars are currently being suffocated by 2 forces: increasingly strict global emission regulations and the absolute physical limits of tire traction. You can only send so much power to the rear wheels before the rubber simply surrenders to the asphalt. At over €3 million, the Fenomeno serves as a proof of concept. It demonstrates that the raw mechanical violence of a naturally aspirated engine can survive modern constraints if it is paired with precise, instantaneous electrical enhancements. The mechanical foundation of this vehicle is a mid-mounted 6.5-liter naturally aspirated V12 engine. Looking at this bare engine block, you are seeing a combustion unit that produces 835 horsepower at a screaming 9,250 RPM, alongside 535 pound-feet of torque at 6,750 RPM. This represents the highest specific power output in Lamborghini's entire manufacturing history. To support this massive output, a compact 7 kilowatt-hour lithium-ion battery is mounted within the chassis. Its primary role is to discharge energy instantly, filling the microscopic power gaps that occur during gear shifts and low RPM acceleration. This diagram compares a standard cylindrical motor to an axial flux motor. An axial flux motor is a compact, pancake-shaped unit that produces massive torque in a fraction of the traditional space. Lamborghini placed 2 of these ultra-thin motors directly on the front axle, generating 148 horsepower each. These front motors execute what engineers call torque vectoring. By instantly applying different amounts of power to the left and right front wheels, the system physically pulls the car tighter into a corner, actively fighting understeer. The third electric component is a radial flux motor mounted directly above the 8-speed dual-clutch transmission, positioned specifically to assist the rear wheels and balance the overall power delivery. Working together, this specific architecture delivers a combined output of 1,065 horsepower. The resulting acceleration launches the car from 0 to 62 miles per hour in 2.4 seconds, pushing toward a top speed past 217 miles per hour. The driver experiences the instantaneous, silent launch of an electric vehicle, immediately followed by the 9,500 RPM crescendo of a traditional V12. Removing the roof from a hypercar introduces 2 severe physics penalties. First, you destroy the aerodynamic flow that generates downforce. Second, you remove a critical structural tie, introducing massive chassis flex under hard cornering. To counter the aerodynamic loss, engineers integrated an S-duct directly into the nose of the vehicle. This geometry channels incoming air upward, creating a heavy vertical load that pushes the front tires firmly into the pavement. For the cabin itself, a newly developed windshield-mounted spoiler catches the turbulent air rushing over the open cockpit and channels it smoothly into the engine bay, maintaining high-speed cooling without drag. To restore the rigidity lost by cutting the roof off, the Roadster relies on a multi-technology carbon fiber monofuselage. This advanced hub serves as the structural anchor for the entire vehicle. The front crash structure utilizes a specific manufacturing process called forged composite. Unlike traditional woven sheets, forged composite involves pressing chopped carbon fibers and liquid resin into complex, solid shapes. This results in supreme structural rigidity at a fraction of the weight of steel. Through these meticulous countermeasures, Lamborghini managed to preserve the car's dynamic stability while keeping the dry weight at just 3,907 pounds. They successfully mitigated the massive penalties of a roofless design without bloating the vehicle's mass. The Fenomeno Roadster belongs to a lineage that started back in 2007 with the Redefine. Lamborghini calls this their few-off strategy. There is a very specific economic model at work here. By limiting production to just 15 units globally, the automaker is effectively having its wealthiest clients crowdfund its own real-world research and development. These 15 buyers will be stress testing extreme components on the open road. This includes bespoke Bridgestone Potenza sport tires formulated specifically for the hybrid torque, and carbon ceramic brakes capable of bringing the car from 62 miles per hour to a dead stop in just 98 feet. These hypercars are effectively prototypes hiding in plain sight. The advanced aerodynamics, the forged composite manufacturing, and the battery management systems tested on the Fenomeno will filter down to Lamborghini's mass-production supercars over the next decade. The Fenomeno proves that high-performance hybridization can actually enhance the visceral characteristics of a large displacement engine. Does this represent the technical peak of internal combustion, or is it simply a stepping stone toward a fully electric hypercar future? Let us know in the comments.